So, yesterday, or the day before, I can't really remember. Was it yesterday? Yeah, it was yesterday. We were talking about simplifying square roots. And so if I had like the square root of x to the sixth, remember what that came out to be? X to the third. You just took half of whatever you had in there, right? So the square root of x to the, I don't know, 20th would just be x to the 10th. And then we were like, okay, well, what happens when that exponent is odd and you can't just take half? So if I had the square root of x to the 27th, let's say, what did I do?
9 and 3.
I just break it down. I go down by 1. So I make it x to the 26th times x to the 1st. And then the square root of x to the 26th is just x to the 13th. And I have that square root of x that's kind of left over. Okay? So you try this one with an odd exponent just to make sure that we remember and we're good. How about 31?
X to the 15th times squared.
I think that was correct what I heard. So I'm going to split it up into x to the 30th and x to the 1st. And then that becomes x to the 15th, and then I just leave the square root of x. Okay, so everybody's okay with it in square roots? Yes? Is everybody with me?
Yes, ma'am.
Because now things are going to get funky. Clap, 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 clap your hands.
So basically, you literally just minus 1, divide that by 2, and then put it and then put it outside of an x.
When it's a square root, absolutely. All right, so now let's talk about having a cube root. All right, so, well, let's just recap. The reason why that was, remember, it's x to the third times x to the third gets me x to the sixth. So that's why the square root of x to the sixth was x to the third. All right, if I'm going to do cube roots, though, so let's just look at, okay, cube root land now. So if I did x times x times x, what does that get me? X to the,
X.
well, what's x times x times x? X to the third, right? So doesn't it make sense that if I took the cube root of x, what will come out? Just x, right? So the, oh,
Wouldn't it
wait,
be
sorry.
1/3 x?
Sorry, I meant to put the 3 there. So the cube root of x to the third is just x. Let's do another one. What would x squared times x squared times x squared get you? X to the
8.
6th.
Wow.
You add them.
But isn't it 2 times 2 times 2?
No. You add the exponents. Because remember what that really means. X squared is this times another x squared times another x squared. Aren't there 6 of them all together?
Oh.
Yeah. So what would the cube, oh, I didn't mean to put an equal sign there. What would the cube root of x to the 6th be? X squared. Right? Because isn't it x squared times x squared times x squared is what gets me x to the 6th? So if I took the cube root of x to the 6th, it would just be one of those. Okay? We'll do one more. Or maybe not. Maybe a bunch more. Who knows? Let's jump up. Let's say I had x to the 5th times x to the 5th times x to the 5th. That would be x to the
25th. No, 15.
15th. Someone said something that wasn't right. So what would the cube root of x to the 15th be? X to the 5th. Are you noticing some sort of pattern happening? True. Like if I asked you, okay guys, what's the cube root of x to the 30th? Could you see how to jump right to that answer?
You just divide it by 3.
Correct. I'm basically just taking whatever my exponent is and I divide it by the index. That's it. You do the same thing for the square roots. It's just that, so if I look back at a square root, remember there's a teeny tiny 2 there that we never write? You're still doing that. 6 divided by 2 gets me 3. 20 divided by 2 gets me 10. 27 wasn't even, so I had to split it up, right? So that's basically my the way that I find any of these. Take the exponent and divide it by its
What
index.
happens if it's not a multiple?
Well, that's when things get funky. So we'll do that in a minute. Okay? So let's put a big star here. So to simplify, any radical, because that same thing is true whether you're doing a fourth root, a fifth root, a 10th root, it doesn't matter. To simplify any radical, take the exponent of the variable and divide it by the index. So if we had just an example with, so if I had some index, I don't know, let's call it, let's put an A right there for whatever the index is, x to some power b, let's say. The answer would always be x to the b divided by a. So let's try a couple more. Say I asked you for the cube root of x to the 39th. That would get you x to the
13.
13. I'm going to switch it up here a little bit. I'm going to change your index on you. How about square root of x to the 44th? Would be x to the,
20.
what did you say?
No, I was going to say 22nd.
You're right. Because this is a square root, so I would do 44 divided by 2, right? So now, I know we're not talking about fourth roots right now, but it all works the same way. So if I had the fourth root of x to the, I don't know, 20th, that would just get me x to the
4.
5th. Because I'm going to do 20 divided by 4. Whatever the exponent is, divide it by your index. Is this okay?
Yes.
So let's make it a little bit more interesting. What if I asked you for the fourth root of x to the 16th, y to the, I don't know, 32nd? What'd that get you?
X to the 4, y to the
That's it. Right? I'm just taking the exponent divided by the index. Let's go back to a cube root one. Let's just throw a number in there. Why not? 8x to the 9th, y to the 15th.
X to the 3rd, y to the 5th.
Why would it be an 8?
Because nothing from the 3 fits in the.
Remember, you want to do the exponent divided by. This is just cube root of 8, which you know. You know what the cube root of 8 is.
2.
It's just 2. So this whole thing comes out to just be 2. X to the 3rd, y to the 5th. Is that okay? Now, yes, everything gets weird once I try and take a cube root of something that's not divisible by 3. So, we need to kind of work our way through that. Are you ready? Okay, so I'm going to start a new page. What happens when, what happens when the exponent is not divisible by 3? We're going to just stick on to cube roots for a few minutes. Is not divisible by 3. So I'm going to try excuse me, and take the cube root of x to the 10th, let's say. I can't do 10 divided by 3. I mean, I can, but I'm going to get decimals. So if I'm trying to simplify this, I'm going to break it up very similarly to how I've done in the past. Oh, you know what? I love that this is erasable. Can we change yours to, oh no, why is it not erasing very well? Oh, there we go. Can we change it to x to the 11th? Sorry. You'll see why in a minute. So cool. All right. So remember yesterday how if I was trying to take a square root and it was odd, I broke it up and I just broke it down. I did one lower. Well, I can't necessarily do that same thing. If I broke this up into the x to the 10th, I'll write this, but you don't write this. If I did the same thing and I just went down by 1, I can't take the cube root of x to the 10th either. Because I can't do 10 divided by 3, and I can't do 11 divided by 3. So I'm not going to break it up into these two, because that doesn't help me any. However, what could I break it up into? Well, I can't do 11 divided by 3, and I can't do 10 divided by 3. But couldn't I do 9 divided by 3? So let's break it up into x to the 9th. And then what would this one be? X to the 2nd. Because x to the 9th times x to the 2nd really is x to the 11th. So I would write this down, because that's correct. So you don't necessarily just go down by 1. You might go down by 1, but I might have to go down by 2. I just need to keep going down until I hit a multiple of 3. Now I can simplify this one. What is the cube root of x to the 9th would be x to the 3rd, right? Because I'm just doing 9 divided by 3. And then this can't be simplified. So that just stays as it is. Here's another time that you need to be really careful. Like your exponents need to look like exponents. The index needs to look like an index. Because if you kind of write them too close to each other. Like what if I wanted to do like x squared, or I don't know. Let's just pretend I was trying to write this number. If I wanted x to the 3rd times the square root of 2, right? If you don't write it clearly, you could read this two ways. Is that x times the cube root of 2? Or is that x cubed times the square root of 2? You know what I mean? So you got to make sure that you're being very clear with whatever you mean. It's obvious. Oh, so awesome. Though it's not really... Oh yeah, it kind of is. Do you know if you can use any eraser to erase these pens? Or does it have to be this eraser? Okay. Let's try the cube root of x to the 31st. So I can't do 31 divided by 3. So I'm just going to keep going down until I hit a number that I can divide by 3. Can I do 30 divided by 3? Of course I can. So in this case, I do just go down by 1. But it's not always going to be that way. You either go down by 1 or you go down by 2. Because someone should be divisible by 3. So this first thing is now x to the 10th, and then that just stays cube root of x. Okay, you try this one. Cube root of x to the, let's do 26th. Okay, you got it?
No.
Oh,
What
dear.
was 26 three times? Simply.
Nothing. That's why you gotta split it up.
So then what do you do?
So you ask yourself, okay, I can't do 26 divided by 3. Go down by 1. Can you do 25 divided by 3?
Yeah.
Evenly, nicely.
No.
No. So then go down another one. Can you do 24 divided by 3?
Yes.
Yes. So you split this into the cube root of x to the 24th, and then what would this one be?
8 or no. 3.
Wait, what was the original number?
26.
So then 2.
So it's just a 2. These two numbers have to add back to that. But now, Ryan, what is the cube root of x to the 24th? That would be x to the what? 8th, correct. So I'm just doing 24 divided by 3. And that can't be simplified. Does that make sense? Okay. Let's put some together then, maybe. How about the cube root of x to the 18th, y to the 7th.
So do you, when you do these, do you just do it one by one? So first you do the x's, then you do the y's?
Correct.
So when you do this, you can only take away 1. You can't add 1.
Right. You never want to add any.
Okay.
You just want to take away. You could take away 1. You could take away 2 if you had to.
I think I got it.
So, first I might split them up. I'll handle the cube root of x to the 18th, and I'll handle cube root of y to the 7th. Kind of like they're two separate little mini problems. What is this? X to the 6. This one doesn't have to be split up. I can do 18 divided by 3. So that one's a nice one. This, I can't do 7 divided by 3 evenly. So this one does have to get split up. So I can't do 7 divided by 3. So then I ask myself, can I do 6 divided by 3? Yes. So this will be y to the 6th, and this will be y to the 1st. What is the cube root of y to the 6th? Y to the 2nd. So now I just have the x to the 6th from before, and that just stays. And that's the best I can do. Did you get it? Now we're going to make things real funky by throwing numbers back in. So, what if I asked you to do the cube root of 80 x to the 17th? So first step, I'd split them. Start with cube root of 80 and the cube root of x to the 17th. So you did problems just like this last night. So do exactly like you did last night, and then try with this and see if you can get a final answer.
So for the 80 to the cubed or whatever, do you have to bring it down to 64?
No. You need a number that divides into 80. So you
Wait.
gotta look in that perfect cube. Yeah, 8. So 8 divides into 80. So this splits into cube root of 8 times cube root of
10.
10. What is the cube root of 8? 2.
2.
And then the cube root of 10 just stays. So that chunk is done. Now I come over here and I say, okay, I can't do 17 divided by 3. Can I do 16 divided by 3? Can I do 15 divided by 3? Yes. So I split into cube root of x to the 15th and the
wait.
cube root of...
15 is not one of the perfect cubes yet.
Doesn't matter. For exponents, the rules are different. The exponents, you just do the exponent divided by the index.
Oh.
It's only when you have numbers that you have to use that list over there. So what is the cube root of x to the 15th? X to the 5th. And then that just stays, cube root of x. So now to write...
Second, took 2 out.
Oh, yeah, you're right. Thank you. Sorry. So now to write this final answer, anything that's not under a radical gets put out in front. So you'd have 2x to the 5th. And then you're not going to have 2 cube roots. You put them together under one big one. So I'd have cube root of 10x squared. Just like that. And you're done. Okay? So if there are numbers, you gotta handle each piece by itself. So the only way they get more complicated is just adding more pieces, but you just do the as its own mini problem, and you should be okay. All right, are we ready to try some?
Can we do it on the board?
Yes, we can. Okay, let's stop this.